What is Wi-Fi? Wi-Fi is the name of a popular wireless networking technology that uses radio waves to provide wireless high-speed internet and network connections. A common misconception is that the term Wi-Fi is short for wireless fidelity. However, this is not the case. Wi-Fi is simply a trademark phrase that means IEEE 802.11x. The Wi-Fi Alliance is a global non-profit organization that deals with products from different manufacturers that are certified on the basis of the IEEE 802.11 standard for the operation of various wireless devices. The Wi-Fi Alliance's goal is to attain a single, worldwide standard for high-speed wireless local area networking. As of 2011, the alliance included about 300 companies. The organization launched the Wi-Fi Certified program in March of 2000. It offers a widely recognized designation of quality and interoperability, and ensures that certified Wi-Fi enabled products provide the best quality and user experience. The Wi-Fi Alliance has certified more than 10,000 so far, promoting the extended use of Wi-Fi services and products in established and newer markets. Prior to 1999, the Wi-Fi Alliance was known as the Wireless Ethernet Compatibility Alliance (WECA). 802.11b is one of several Wi-Fi standards developed by the Institute of Electrical and Electronics Engineers, or IEE. It was released in 1999 along with 802.11a as the first update to the initial 802.11 specification, published in 1997. Both 802.11a and 802.11b are wireless transmission standards for local area networks, but 802.11a uses a 5 GHz frequency, while 802.11b operates on a 2.4 GHz band. The 802.11b Wi-Fi standard provides a wireless range of roughly 35 meters indoors and 140 meters outdoors. It supports transfer rates up to 11 Mbps, or 1.375 megabytes per second. In the late 1990s, this was significantly faster than internet speeds available to most homes and businesses. Therefore, the speed was typically only a limitation for internal data transfers within a network. While 802.11b provided similar data transfer rates as 10BASE-T Ethernet, it was slower than newer wired LAN standards, such as 100BASE-T and Gigabit Ethernet. 802.11a is an IEEE standard for transmitting data over a wireless network. It uses a 5 GHz frequency band and supports data transfer rates of 54 Mbps, or 6.75 megabytes per second. The 802.11a standard was released in 1999, around the same time as 802.11b, while 802.11b only supported a data transfer rate of 11 Mbps. Most routers and wireless cards at that time were manufactured using the 802.11b standard. Therefore, 802.11b remained more popular than 802.11a for several years. In 2003, the 802.11a standard was superseded by 802.11g, which uses the same 2.4 GHz band as 802.11a. but supports transfer rates of up to 54 Mbps. (802.11g). The specification is a standard for wireless local area networks (WLANs) that offers transmission over relatively short distances at up to 54 megabits per second (Mbps). Compared with the 11 Mbps theoretical maximum with the earlier 802.11b standard. Networks employing 802.11g operate at radio frequencies between 2.400 GHz and 2.4835 GHz, the same band as 802.11b. But the 802.11g specification employs orthogonal frequency division multiplexing, or OFDM, the modulation scheme used in 802.11a. To obtain higher data speed, computers or terminals set up for 802.11g can fall back to speeds of 11 Mbps. This feature makes 802.11b and 802.11g devices compatible. 802.11n uses multiple input multiple output, or MIMO technology, and a wider radio frequency channel. It also provides a mechanism called frame aggregation to decrease time between transmissions. Current WLAN technologies require that the sending station request the channel, send one packet, release the channel, and then request again in order to send the next packet. With frame aggregation, once a station requests the channel and has the authority to transmit, it can transmit a series of frames without having to release the channel and regain authority for each frame. With 802.11n, raw data throughput is expected to reach as much as 600 Mbps. That's more than 10 times the throughput of 802.11g. Although the IEEE began work on 802.11n in 2004, progress in ratifying the specification was stalled by competing vendor groups. Draft 1 of the standard was released in 2006 and pre-N equipment became available shortly after. Draft 2 was approved in 2007. Pre-N equipment has demonstrated a data rate as high as 540 Mbps with typical rates between 100 and 200 Mbps. Data rates are expected to increase as experience with the standard grows. 802.11ac, also called the 5G Wi-Fi, is the fifth generation of Wi-Fi technology, standardized by the IEEE. It is an evolution of the previous standard, 802.11n, that provides greater bandwidth and more simultaneous spatial streams. This allows 802.11ac devices to support data transfer rates that are several times faster than those of 802.11n devices, unlike previous Wi-Fi standards, which operated at a 2.4 GHz frequency. 802.11ac operates exclusively on a 5 GHz frequency band. This prevents interference with common 2.4 GHz devices, such as cordless phones, baby monitors, and older wireless routers. Computers and mobile devices that support 802.11ac will benefit from the 5 GHz bandwidth, but older wireless devices can still communicate with an 802.11ac router at a slower speed. The initial draft of the 802.11ac standard was approved in 2012, but 802.11ac hardware was not released until 2013. The initial 802.11ac standard Wave 1 supports a maximum data transfer rate of 1300 Mbps, or 1.3 Gbps, using 3 spatial streams. This is significantly faster than 802.11n's maximum speed of 450 Mbps. It also means 802.11ac is the first Wi-Fi standard that has the potential to be faster than Gigabit Ethernet. The second 802.11ac standard Wave 2 will support twice the bandwidth of Wave 1 devices and offer data transfer rates of up to 3470 Mbps. 802.11ax is the next generation standard in Wi-Fi technology. Wi-Fi 6, also known as AXW Wi-Fi or 802.11ax Wi-Fi, builds and improves on the current 802.11ac Wi-Fi standard. Wi-Fi 6 was originally built in response to the growing number of devices in the world. If you own a VR device, multiple smart home devices, or simply have a large number of devices in your household, then a Wi-Fi 6 router might just be the best Wi-Fi router for you. In this guide, we'll go over Wi-Fi 6 routers and break down how they faster, increase efficiency, and are better at transferring data than previous generations. 802.11ax is designed to operate in all ISM bands between 1 and 6 GHz when they become available for 802.11 use, in addition to the 2.4 and 5 GHz bands already allocated. Devices presented at CES 2018 claimed a combined 11 gigabit per second of theoretical data rates. For dense deployments, throughput speeds are 4 times higher than IEEE 802.11ac, even though the nominal data rate is just 37% faster at most. Latency is also down 75%. To improve spectrum efficient utilization, the new version introduces better power control methods to avoid interference with neighboring networks, orthogonal frequency division multiple access or OFDMA, higher order 1024 QAM, and uplink direction added with the downlink of multiple input and multiple output or MIMO and multi-user, multiple input, multiple output technology or MIMO to further increase throughput, as well as dependability improvements of power consumption and security protocols such as target wait time and WPA3. Wi-Fi 6 allows more devices to connect and stream simultaneously, without impacting speed or reliability, by scheduling up to 12 streams at once and efficiently packing and scheduling data. The results deliver the fastest Wi-Fi to all your connected devices of today and tomorrow. These are the Wi-Fi's maximum data rates.